everyone, Johnny F4X here again, this time with a crash course on resistors. This is not going to be a bunch of Ohm's law technical jargon. You should all know by now that it states voltage equals current times resistance. Thank you to George Ohm for that, and thank you to Otis Frank Boykin for inventing the resistor. Those little buggers save us from frying our devices and controllers on a daily basis. Alright, on to the fun stuff now. Figuring out what a resistor's value actually is. We have all seen and used or tried to use the beloved color code band charts to figure this out, and I'm going to try and show you how to do that real fast here, and then a couple of your other options, including but not limited to a voltmeter like this, a multimeter like that, ohm meter like this, which is a homemade DIY on your Arduino Uno using either the serial monitor in your Arduino IDE or Bluetooth with an HC06 and a Android app called Arduino, which is a very good serial analog receiver over Bluetooth. I've used it frequently. It's a freebie. You get the little ad that pops up, and once it goes away, you can see on your screen here, hopefully, it's measuring the current voltage of this resistor right here. And if I pop that out, you'll see it bounce out, shoot to 0 voltage, and up to crazy amount of resistance. And I'll show you how to build one of these and measure some resistors with it here shortly. So let's move on here to some other goodness on this color-coded bar chart that we pull our hair out over. Alright, when it comes time to taking a look at your resistor to try and figure out what size it is, 10K, 220K, a million, part one you want to take care of is making sure you have it pointing in the right direction when you're reading it and comparing it to the chart. Best way to do that is take a look at the one on the screen, and you'll see a gap in between the color bars. Wherever the biggest gap is, typically you want that on the right hand side. In this picture here, this is a perfect example of it. The second problem you may run into is the different shades of color. It's not consistent across all manufacturers or age of the resistor for that matter. Reds may look like browns, yellow may look like golds. So take that into consideration when you're measuring these. If you're not sure, then get a digital meter, voltmeter, etc. to try and figure the numbers out. But if you're going to take a shot at it, look at this one here we have on the screen right now. That first band, in this case, it is a red, which is a number 2. The second band is also red, which is a number 2. The third band appears to be black, which is 0. So we have 220 right now. Fourth band is orange, which is a 1K multiplier. So 1K times 220 is 220K. It's a 220K resistor. And the far right band that you see here is actually a brown, which means it has a plus or minus 1% tolerance. So that's it in a nutshell. That's the trick to it, all that's to it. Sometimes it works, sometimes it doesn't. Your eyes and its colorization will determine that. Good luck. Okay, so does this look familiar to anyone? Trying to get that resistor to stay still when you try to get the multimeter probes on it just to get a measurement, and try again, and it's like playing hockey with little metal wires. You finally peg it, and then you lose track again. I'm sure we've all had these Arduino projects and Arduino kits that we've gotten, and we swear we're going to keep everything organized, and before we know it, we have a pile of resistors that we need to get measured and put in the right place so we don't use the wrong size and the wrong device and wind up frying something we built or bought. This is where we're going to learn something new here, how to measure things a little quicker with a new device. Alright everyone, welcome back, and let's start measuring some resistors. So this is the final step of this video here. If you jump to this, good for you. If you enjoyed the rest of the information, yay for me. What we have here is our traditional Arduino Uno in the back. That's actually an original, which I rarely ever use just because I like to have an original. I don't want to break it. Up here we have an HC06 Bluetooth connector adapter. I've been using these for quite a while. I don't use voltage dividers on these, even though everyone says they should. I run a full 5 volt into that without any issues. Your call on your side if you want to do that or not. Now I'm going to show you the app real fast here. On the phone here on the left, first thing you're going to want to do is get your Bluetooth fired up as you normally would. You can see here HC06 is already listed in mine. So let me tap out of that and that. So like I mentioned, the app is called Arduino. It's up on the App Store. I've used it many times. Once you open it, you should see your Bluetooth devices listed, the ones that you currently have paired to your phone or have paired to your phone in the past. There's HC06 again right there. We'll open that guy up. We want to use this as a receiver in this configuration. Next step, you just want to connect. So hit this little lock guy down here to link. And now it'll start to try and talk to your HC06 guy here. Bluetooth device connected, and there's the free commercial for your daily viewing. Just close out of that. Now it's connected. You can see the lights stop blinking on the HC06, and it's taking serial input now on the Bluetooth receiver sent from the analog. This is using Bluetooth serial, by the way, the BT serial library. Works just the same as serial, but it's firing it off out the basically TX RX, but in the software fake out. Right now we have a 220K known resistance resistor here. That's the caveat to using this to measure any of your resistors. You need to have a known resistor to start with here, initially connected to these guys. When I say these guys, I'll show you the pin out and the wiring in a document. It's very easy. You've got one running to hot, one running to ground, one running to analog. 220 at the front part of the rails here in the back plane, and then we're going to voltage divider here with the other resistor, and it should show up over here. So let's give one a shot, and let's fire this one up. Now I'm going in between the resistor, the existing resistor, and this is a 330K resistor that I just popped in there. I know that for a fact. Now it says 334. The tolerance when you get up to that level in the thousands, you're going to actually, if you divide it out, that's really actually very acceptable. So 334, and at least you know you're on the right track. If you really want exact numbers, go ahead and get yourself an official OhmMeter or voltmeter. Then you get your exact numbers. But you see how easy that was. Boom, popped in, popped out. I know that's a 330. So we'll put him to the side. Let's grab another one here. I don't like that one. I'll show you why in a moment. Some of the resistors, a lot of the resistors actually that we get in those kits, very thin pins on them. And that is a 270K resistor I just put in there. 270K on that guy. And I know that again because I just popped it out of one of the Ziplocs that I have them in. When I say in Ziplocs, I did not put them in there. I got all my new resistors from a company called Joe Knows Electronics. And when they ship them in nice, well-organized Ziplocs. 86 different resistances. 10 of each for 20 bucks. You can't beat it. And they're real easy to work with compared to the little itty bitty ones. I'll pop a picture up on the screen as well, but you can see the differences in the pins. Now, this is for measuring the higher voltages in here, higher resistances, 220K. If you're going to be measuring lower resistances, you're going to want to change this known resistor in here to something closer to the range that you're measuring. If you're going to be looking for 1K, you're going to want to put a 10 or a 5 or something down in that range. That's the key to making this work even somewhat accurately, is get that known resistor established close to the range that you want to be measuring in. Let's see what this guy shows up as. There's a 220 that I just popped in there. So again, this is a known 220 here. It's been that way the whole time, measuring that 270 and the 370 that we measured. I just put a 220 in here to measure to see what it was, and it showed up as a 220. So pretty accurate when it's closer to the known resistor. Hope that makes sense. Let me pop that out. That's it in a nutshell. The extra lines you see in the back here are all running to the HC06. You've got your positive, your negative, and your 2 pins, TX and RX. On this, they're running to, I think, 10 and 11 I have set for software serial. You'll see that in the code. I'll include that in a Google Share, Drive Share. And in a nutshell, if you're in a pinch and you need a voltmeter, this should do it for you as far as ohms go and getting your resistors organized relatively quickly. Let's try one more here and see what happens. I should pop one in there to show you what happens if it goes haywire. And that's another 330K right there. But I wasn't playing hockey with the probes from the voltmeter on the table, so that's a big plus right there. And I wasn't trying to read the pretty color bands on them either. So I hope this helps you guys, and that's about all I got. Any questions, let me know, and y'all have a great day. Bye now.